When we think about trends, right, the first thing that comes to our mind is probably we are speaking about something that's far ahead in the future, right, or something that's maybe inspiring but not relevant just as yet today. But the beauty of the 10 trends that Bharani and myself we have picked up for you is that these trends are relevant today, now. And when you walk out of this conference today, you can start applying them in your daily business. And that's the beauty of, meeting the intersection of inspiring technology, which is relevant right now from today. We are the head of tech for Thoughtworks India, myself, Vanya, and we have Bernie here. And for the first trend, I'm going to pass on to my friend, Bernie.
Hey, good morning. Audio okay? Yeah. Okay, like Vanya said, all these trends we've picked in a way that no matter what your background is, this should make sense to you. So hopefully you will take something new out of these 10 trends. So the first trend I want to kick off with heads or tails in observability, right? I mean, I'm pretty sure you can relate to this, right? Like pretty much everything starts with someone having a vision saying, I'm going to build a platform, right? You all resonate with this, right? Like this is a trend in 2023, and then soon after that, right, you would have this question, oh, should I be building it or should I be buying it, right? And we keep going back and forth on this, and usually the answer that we give is, it depends, right? But we have a better answer, right? It's not build versus buy anymore. You are composing. So if you're building or buying, it doesn't matter, right? The demands of the current generation of apps is in such a way that there cannot be one single product that can fulfill all your needs. So you will be composing, be it an AI-driven thing or multiple products into a rich experience. So given that you're composing, the point I want to highlight is you're composing multiple distributed systems, right? And that is the catch, right? Each of them, under the line, there would be tons of APIs, number of databases. So there are lots of moving parts, right? So, and when you have lots of moving parts, you do expect failures, right? Somewhere in day 2, day 3, day 10, one of your DBs may go down or out of space. One API may be going slower because of that. And all this, you will see the effect of that in your end application. And what do you all do? What do you do in this? Like, how do you support such a diverse ecosystem? You can be interactive as well. Yeah, you do monitoring, you do observability. The thing with observability is that you don't just monitor your application, because no application lives in isolation nowadays. They all talk to every part of your enterprise ecosystem. So what you ended up doing is that you ended up observing your entire IT landscape, right? Which is good. We are encouraged to do that. The only downside is that, at what cost? So if you look at your cloud bill, let's say you are paying $100 for your systems put together, the cost of your observability stack itself will be equal to or more than $100. Have you felt that? I see a few people smiling. Why is that? Why is that your observability stack is costlier than your production system? So an easy answer is you're observing the entire stack and you're absorbing 100% of the traffic, right? Like, and this is because you don't know when you're sampling. If I do a sample on my entire traffic, and let's say I'm sampling 20% of my traffic, it's possible that your error is not in that 20%. So you have no idea if your business is running good or bad, right? All your operational report will say you are fantastic, everything is green, but you will still have those errors lurking in the system. So because of that, what do? We observe the 100% of the traffic, and then the bill goes up. This has been the case for a pretty long time until now, right? Now you have something called tail sampling, right? And this is the heads of tails. When you do a tail sampling, what happens is that you defer the decision of sampling till your process is complete, till the last leg of your request response is done. Let's say through the entire journey, you're calling 10 services and the 9th service fails. or the ninth call to the database fails, you can defer the decision of sampling towards the end so that you can now say, I want to capture all there is and some percentage of my normal traffic, right? So imagine if you just observe only the error and discard everything else, you see how the math works, right? Suddenly, you don't have to change your code, you don't have to change your observability stack. If you have embraced open telemetry, this is now part of the open telemetry collector. So no matter which tooling you use, as long as you use the open telemetry collector, you have tail sampling. And that's immediate saving for your enterprise, right? So that's the first trend I want to highlight. Okay, so we move on. Okay, so I'm going to changing the gears now and talk about security. Right. So yeah, let's have an answer. What's the most important thing that you worry about when you're building a cloud-native applications now?
And we need answers for that.
Yeah. What's your biggest concern? Data, identity. What's your concern? Compliance. What else? What else in compliance? What is it that you worry about? Privacy, security. Yeah, security concern. What's the most important security concern? Secret keys. Someone is saying that. Credential. Yeah. We know how to send things to space. We know how to successfully land things outside our own ecosystem and all that. But we keep making the same simple rudimentary mistake all the time, right? We keep checking in secrets in our source code. We all know that that's bad, but even the best knowledgeable person in your team on a bad day can make this mistake, right? And that's inevitable. So the entire industry, the only solution that we have is, have a big eye monitoring your commits, and if it resembles anything like a secret key or a token in your source code, you have tooling to say that, this is bad and stop it, which is fantastic, but we still have breaches. Why? Because I know pretty much it's a muscle memory for people to say hyphen ignore and then push it in, right? Yeah, that's the problem we face as an industry. But the trend I want to highlight is that we need to learn how to work with secrets, right? And that's so fundamental. You'll hear more about secrets when Vanya talks about another trend. But this is the point I want to highlight, is that ask yourself this simple question. What happens when you check in secret? Is there a way that you cannot, you are going against the human nature to make a mistake and with all this tool. So what if there is a solution that lets you check in secrets in plain text, but except that the tool comes in between you and the storage. So when you check in plain text, it understands your configuration, it understands you're having a key and a value, and it'll only encrypt your value, right? Very transparently. So when you do a Git history and you compare, you will have your config file in plain text, but anything that looks like a secret will be encrypted automatically, right? And that's the tooling. The tool is called Mozilla SOPs, or SOPs in general, for secret as ops. And it's fantastic. So if you know encryption, so it adopts envelope encryption. So every document gets its own private key, right? You can have your own master key, and then the master key is used to encrypt the new data encryption key that is in the file. So, and it can work with almost all cloud key management services out there. And it's pretty tiny, right? And the tool itself does not encrypt anything. So you give an encryption algorithm and it will do that for you. So that's secret ops. So I'm not saying all the tooling that you have out there to monitor keys is void. This is a complement to whatever toolings you have to protect your secrets. But know that you need to know how to manage secrets, right? Good?
Oops. All right. Thank you, Bernie. In order to understand the next trend, let's take a small analogy. Imagine you are shopping at pick any favorite platform that you shop at, Amazon, Flipkart, Mintras of the world. The question is, would you buy a product whose seller you cannot identify? Would you buy a product whose reviews are not mentioned? You cannot figure out what and how people have been using it and what's their feedback on it. Or would you buy a product whose quality metrics are not published? For example, if you're making a purchase for an air conditioner, I'm sure you would want to know its energy rating or energy saving, right? Without that information, it makes it a little hard. My whole point is that product thinking is not a new concept, right? It happens at the intersection of what's viable for the business, right? Whether it's desirable by the user and whether it's feasible, of course, not from a technology and technical standpoint, right? If we look at, the technology ecosystem as well, product thinking has proved extremely beneficial construct for all of us, right? Right from building a website, a mobile app, a web application, or even platforms these days, right? Product thinking is paving the way all through and through, right? Now, my whole proposition is how can we bring all of this goodness to the data and analytics ecosystem as well? Right? What it really means is how do you think about your data consumers as your customers and try to create delightful experience for them? Now, what does data as a product really would mean? I should think about what's the business value for this data, right? What are the insights that I can derive from this data to better my business, to better my customer experience, right? Whether this particular data as a product or data that I'm thinking or trying to apply product thinking to is usable, right? Is it going to serve some purpose for my data consumer, right? And last, it needs to be composable. We all understand that in order to derive any value out of data, it needs to be composable, right? I need to be able to join data. So all these three things put together gives rise to the thinking of data as a product or data product thinking, right? Now, keep this thought process aside for a moment. And I want to introduce another concept called FAIR, F-A-I-R. So FAIR stands for findable, accessible, interoperable, and reusable. And for those who are probably from the data and AI ecosystem would probably already know that FAIR is a regulatory standard for data management, right? It's widely accepted across the globe. And for if you really want to think about a compliance-oriented data management ecosystem, then you have to think about the FAIR principles, right? Now, my proposition to all of you is that if you think of your data as a product, you will be able to comply with the FAIR principles. The top 4 questions to ask are, is my data findable? The first one, the F of the FAIR. Now, when I start to think of my data as a product, I need more and more people to use it, right? Because it's a product. And I'll be delighted if more and more consumers are using it, right? So I will think about making my data product findable, discoverable, right? The kind of technology that we are using for that today is, say, a data catalog, right? Where the data consumers can go in and search for what are the various data products that are listed for my use, right? Now, the question comes, how will a user who's looking for the right data trust this data? That's where the quality metrics come in. Can I transparently also publish my quality metrics, like what's the freshness of this data? What's the consistency of the data? And what's the availability, right? If all of these metrics are available, it's going to help my consumers trust my data more, right? So that's the aspect of making sure that I am thinking about how will data consumers find my data easily and are able to trust it and also understand it. Now, the understanding part talks about, am I publishing relevant technical metadata about my data products? Am I publishing relevant business metadata about my products, right? So when you think about findability, think about 3 things. Is my data discoverable easily? Can my consumers easily understand the data? What is its purpose? What can be its value? And third, can they trust it? So if you think about these 3 things, you make your data findable. The next question to ask is my data accessible? Now, what use is the data if it's not easily accessible, right? Now, in large organizations, there are very specific roles and authorizations that are required, right? So how do I think about making sure that I can still trigger an automated workflow for requiring access to that specific data, right? There are a lot of tooling out there, which I'm going to talk about eventually. But the point is, can I provide an accessible, addressable URL such that people can automatically trigger automatic request for accessing the data, right? If it's a confidential data, if it's under classification, private and confidential, it should trigger a request to the owner. If it's not a classified data, it should directly give you access based on your authorization to that data, right? So that's the second question. Is my data accessible? The third one, as I said earlier, in order for any data to make sense, you need to join it with multiple other systems, sources, whatnot, right? And that's where interoperability comes into picture. Are you thinking about exposing relevant ports on top of your data such that you can combine it with other data, right? So JDBC is one such example, right? The other example could be if it's an event streaming system, are you publishing your event spec in platform agnostic ways such that people understand how to make sense of your event and then they can do whatever they want to with it, right? And the last thing, the most important, because we are thinking of our data as a product, it's not a single time use, right? I'm not solving for a point problem today, but I'm thinking about long lived products, right? And that's the difference, right? When you go from point solution to building a data product which can evolve and support more and more use cases in the future, you have achieved a good nirvana state of data product thinking. Right? So that's my first trend for all of you. And these are some of the toolings that I wanted to highlight. When it comes to findability, Colibra is one of the data governance and data cataloging tool that we widely use across Thoughtworks. It's sort of heading towards the governance space as well. Then there is Monte Carlo. It's a fantastic tool, open source, for doing data observability end to end. You can monitor your pipelines, you can monitor your models, and it also has automatic remediation features, right? So it's a fantastic tool. We have been using it successfully across many projects. And there is Soda. Soda is a data quality tool with which you can automate some of the integrity constraints that you want to codify as part of your pipelines using Soda, right? So some of these are great tooling, and Immuta is one in the accessibility space, right, where you can make sure that you can do attribute-based access on top of your data to allow for different granularities of usage and access to your data. With that, I'm going to move on to the next trend, and this is, by the way, one of my favorite. This is about the fallacy of developer productivity. Now, I'm sure all of you, some of you might be engineering leaders, right? Team leads, tech leads, developers. And developer productivity happens to be the bone of contention for almost everybody, right? People have been talking about it since times immemorial. And it's an important proposition and concern for almost everybody. But the million-dollar question is, do we even know how to measure developer productivity? More than can we even measure developer productivity, right? Now, okay, what are the metrics? Maybe the number of lines of code. Looks okay. Maybe the number of PRs that I have merged. Sounds okay? No? Maybe the number of bugs that a QA has filed. No? Maybe the number of issues that I have closed today. These metrics, these output-based shallow metrics, I just despise them, right? I mean, it just makes me a little cranky when I look at people thinking about these as the ways to measure your developers' productivity. So here is the catch, right? I'm not against the notion of thinking about developer productivity, but it's not from the perspective of how am I juicing my developers? Are they giving me enough return on investment, right? But my proposition is, if we think about developer productivity from the perspective of developer experience, right? Now, this particular diagram that you see on the screen, I've taken this from this wonderful paper written in ACM by Microsoft Research, GitHub, and a few people from this wonderful tool that I'm going to talk about called DX, developer experience, right? These three entities coming together. And I'm going to quote the definition of developer experience from this specific paper. It says that developer experience encompasses the way developers feel about their work, think about their work, and value their work, right? So it's feel, think, and value. Now, if it's feel, think, and value, do you see what we are talking about here? We are talking about what is the developer perception of their productivity, right? It's not talking about the outputs. It's talking about how do I feel as a developer while I'm doing my day-to-day jobs, right? Because in the entire daily jobs that a developer has to do, there are a variety of tasks, right? There are so many frictions, right? And that's what this developer experience talks about how can I make sure that I provide a seamless experience for my developers, right? Let's look at the three aspects that you see in this triangle here. The first one is the feedback loops, right? How much time does it take when I make a code commit? How much time does it take for the build to run to give me the feedback? How much time does the integration test suite take to give me that feedback? How much time does it really take to deploy something to a lower environment, right? So all of these are the times that people are waiting for something or waiting for feedback, right? Or how much time does it really take when I submit a code PR for the reviewer to review and provide me feedback, right? So all of these are points of friction across the developer journey. Here, the developer is waiting for somebody to respond or somebody to give them feedback, whether it's a machine or a human being, right? So these are the feedback loops. The second aspect of the DevX is cognitive load, right? So cognitive load means how much mental processing is required to understand something, right? There are several elements here. Can I locate my documentation easily? Do I understand the rules of my domain easily? Can I onboard a new person such that they can build the understanding of the system easily? Are my architecture decision records visible somewhere such that I can understand why certain decisions were taken? And so on and so forth, right? So this particular thing is about how do I reduce the overall cognitive overload for my developers to be productive, right? Last but not the least is the flow state. I'm sure all of you have heard this. Today I'm in the zone, or I'm in the zone. Yeah, the statement that means that I am in that full mode or capacity where I am at my best, where I'm able to solve deep, complex problems. Right? So I'm in the flow. I'm in the zone right now. And when you put all of these three things together, of having a good flow state means you need to avoid your interruptions. You need to have good, solid feedback loops and cognitive load, right? So the only way you can get into a flow state is when your feedback loops are streamlined and when your cognitive load is reduced, right? So all of these three things, they facilitate each other to create a seamless developer experience, right? And that's where it's all about, right? That's what it's all about. You have to think about optimizing your entire software supply chain, right? It has to start from how should I onboard a new person? How should I think about my documentation? How should I think about making it available? How should I think about reducing the time it takes to run my build? And how much time am I spending in meetings, right? Because the only way to get into the zone is if my day is not littered with meetings, right? And with that, I want to show you some important metrics. Again, these metrics have been taken from the same paper. As you can see, the first point, the perceptions, right? Satisfaction with automated test speed, right? So all of these metrics that you can read on your screen are so much related to how a developer is spending their time and what are the lived frictions that they experience on a daily basis, right? And that's where I want to feature one very interesting tool called DX. It's DX DevX 360. It's a survey-based tool that allows you to ask these important questions to your developers such that they can talk about their pain points, such that they can also give suggestions on what and how these pain points can be alleviated, right? So that's my idea of developer productivity. And I request all of you to think about not the output-based metrics, but a lot more outcome-oriented, developer experience-led metrics.
Okay, let's change gears again. I know, like, we have people who maintain production systems, SRE teams, however you call it, DevOps engineers. Just show of hands, like, what's your largest transactional system in your company that you maintain? Like, how big is it? Just say a number. 30 terabyte. Was it GB or TB?
TB.
Good. Any other number? Okay. Yeah, so I just want you to, let's take a step back, right? Once upon a time, we just had transactional systems, right? However you wrote your user interface, be it thick client, thin client, doesn't matter, 2-tier, 3-tier, doesn't matter. We only had transaction systems. We had things that will do their work. You will store them in your own database of your choice. And it got the job done, and we're all happy. Let's say hundreds of terabytes, hundreds of gigabytes, no issues, right? We know how to solve the problem. But then we added reports, right? Is there any database administrator in the crowd? And if there is, they will tell you, if you want to do reports, please don't run off the main database, right? It's going to pull things down. So what do they tell you? How do you solve the problem? Yeah. You basically take a replica, right? You take a read replica. So what does that mean? Someone said they have 30 terabyte. You take another 30 terabyte because you want to run reports, right? That's how we do it, right? That's awesome. Okay, it's doable. What did we do? Reports are not enough. I want to have real-time analytics, right? If you're in retail and you're running a promotion, I want to know how my category is doing. This is not your typical select group by join query, right? You need to do a little bit more. And what do you do then? Maybe you use Spark, maybe you use something else. And then you take the same 30 terabyte and you would copy again in its own form, in its own storage. Now what happens? You have another 30 terabyte. Okay, it's 2023, you don't stop there, right? We all want to run models, so not just one model, multiple models, like multiple large language models or multiple machine learning models. And what do? They take another copy. So the point I want to drive is storage is extremely cheap, until to an extent that it isn't, right? You will soon hit a point where you are paying through your nose for just your box stores, right? And this is fundamentally because if you look at what storage options do you have, we all know the file store, the POSIX, like from the Unix days, that's okay. And pretty much most of the transactional systems use a block store, right? It's either your elastic block store or your normal SSDs or you're using hard disks, and that's what they use. But the cloud has made one other store very popular, right? That's your object store, right? The third option, right? Your S3s of the world. And this is like, why am I talking about object store in 2023? Everybody knows this, right? Like if I talk to data engineer, they will say, man, we've been using object store for ages, right? This is where we put our data lakes. This is where I run my Snowflake off. So for the past, I would say 5 or 10 years, even, the analytical world have leveraged object store to a T, right? But transactional workload, your reports, your analytical query, they don't run off object store because there was a limitation, right? You can't have a transactional system on top of S3. That doesn't make sense. Imagine, can you run Postgres off S3, right? Let's say if you do, let's say if there is a solution, right? This is how it will look, right? You will have your normal transactional system write to object store, right? That's read and write, without doing anything else, right? If you have multiple read queries, they will all be reading off the same object store because the storage is common, right? So this is exactly what a startup did, right? These are the core committers of Postgres. So they decided, what if I wrote a new storage engine for Postgres, right? That's extremely cloud native, that is built on top of object store for transactional workload. So basically what it means, your Postgres instance are almost serverless, right? You can create an instance, serve a request, and if you want, shut down the database, right? Think of serverless databases, right? I know a lot of cloud providers do have serverless database offering, but think of it as an open source. This is something you can control. And it is truly serverless in the sense that all the Postgres instances become ephemeral, right? And what can you do with this? You can almost clone your workload without doing a copy, right? Let's say you need to answer one critical question. What if an ML engineer changes data and this is my production data? Let's say in your case, if you are having a 30 terabyte production system and you're giving the same for a machine learning team, If they make a change, the change happens in their branch, right? Think of it like a Git for data. You can branch and you can make changes to the branch without affecting the main copy. And let's say you change 10 KB of data on a 30 terabyte, you only pay for that 10 KB and not for taking an entire copy. So that's how impactful it is. So do check out. So that's Neon serverless Postgres with a new storage engine on top of S3 compatible object stores. All right. I'm gonna change the gears again and talk about the state of WebAssembly. Like, show of hands, how many people know WebAssembly? Not a lot, which is okay. Yeah, it's a proof that as an industry, we still suck at naming things. WebAssembly is neither web nor assembly, right? But somehow we named it WebAssembly. So what is WebAssembly, right? It is just a standard. Let's say you have a number of languages out there, be it anything like C, C++, Rust, JavaScript, Java, doesn't matter. It's a compiler target, right? It's how you compile the bytecodes from your source in a portable, safe, sandbox manner. That's what is WebAssembly, right? Original roots are for it to be run within a browser, but now it is expanded way beyond a browser, right? So that's what is WebAssembly. Now, you would ask, like, why am I talking about WebAssembly now, right? So it's the perfect interaction between I want something open, I want something that is safe, I also want something that is performant, right? Like security and performance never go hand in hand, right? If you have a highly secured environment or you have a highly secure standard, it's very hard to make it run fast, right? But WebAssembly is one of those where you get both, and it almost looks like you are cheating the law, right? That's how it is. Just to say, let's say if your container takes about 250 milliseconds to spin up server request and shut it down, WebAssembly would be in 50 milliseconds or under 50 milliseconds, right? So that is the speed of WebAssembly runtimes. Right, why am I talking about, again, WebAssembly? Like, so if you know, I hope everybody knows Docker, right? So this is Solomon Hykes, the original author of Docker. And this is one of his famous tweet. But he tweeted in 2019 saying that if WebAssembly existed in 2008, he wouldn't have invented Docker, right? And that's how significant it is, which is good and bad in a way, right? And this tweet was from like 4 years ago. Like, where is WebAssembly penetration now, right? It's awesome. It has a lot of promises, but like all standards, it takes time to mature, right? And this is why I want to bring to everyone's attention is that if you're using Docker, you can now run WebAssembly with Docker runtime, right? There is a support for WebAssembly now in Docker. And not just that, if you're using Kubernetes, there is a experimental runtime called Crustlet. So you can have WebAssembly-based container-like runtime, but in WebAssembly in your Kubernetes ecosystem. So it is maturing, and it is in the right time of disruption. So watch out for disruptions in WebAssembly space. And this is how it is evolving, right? Like we all know how we moved from like physical machines to VMs and containers, and we are now at the cusp of like from jumping from containers to WebAssembly. And if you want to know what you can build right now with WebAssembly, like this is a exemplar implementation by the company Fermion. It's a micro CMS completely built with WebAssembly, right? So do check it out. And this is the actual framework. Like you can almost think of Spin as your Spring Boot of the world, right? If you want to run, there is a support in JavaScript, Rust, and TypeScript. So you can write in all these languages, use Spring, compile to WebAssembly, and run it on Fermion platform, right? That's what you can now do with WebAssembly, disrupting the runtime ecosystem. With that,
okay.
Yeah.
Zero trust security for CI/CD. So I'm going to change gears and also speed because we are running a little late. I'm sure all of you have heard about zero trust, right? in the last decade or so, zero trust became a prominent thing because the complexity of the technology ecosystem involved multiple cloud providers, multiple managed services, and of course on-prem as well, right? And inherently, the zero trust concept is about, just a recap for all of you before we move to the actual trend, it's about saying that the network perimeter alone is not a guarantee for your security, right? What it means is that when I think about my users, services, and resources, I need to think about not just where they are in the physical network, I need to also think about a lot of other things, right? So zero trust security, I think we have applied with full rigor into our operational and analytical systems. But when it comes to our CI/CD, I think we have sort of maybe not shown that sort of a rigor. So this trend is precisely about that, to apply the same rigor of zero trust security for your CI/CD systems as well. Because, as you can see, pipelines, they have access to critical data. They have access to the source code, they have access to your credentials, and they have access to your secrets, which help us deploy and build our software, right? Now, what are the 6 aspects that you can think about while you're thinking about zero trust for your CI/CD? The very first one is authenticate your pipelines. The pipeline user just don't have a simple password-based uh, access and authentication for it. Use or authenticate your pipeline user with your cloud provider by using some federated identity mechanism like OpenID Connect, right? Don't let it be a simple password-based thing, but let it be a federated identity authentication with your cloud provider, with your identity system. That's number one, right? The second one is no direct access to secrets. Now, if you are using GitHub Actions, I'm sure a lot of you here are using GitHub Actions. And if you are using, you're using self-hosted runners or you're creating workflows, and in those workflows, there is a need to fetch the secrets. How would you do that, right? And the invitation to all of you is to maybe think of integrating your GitHub Actions with something like a HashiCorp Vault, such that when the workflow runs, the secrets are fetched at runtime, right? So instead of having them as environment variables in your pipeline files, make sure that there is an integration to securely access the secrets while the workflow is running at runtime. So that's one. The third one is ephemeral runners, right? I'm sure, as I said earlier, if you're using GitHub Actions, it's likely that you're using self-hosted runners. And make sure that when you're using those self-hosted runners, they are ephemeral in nature. That means every time a workflow gets triggered, a new runner gets created. Do not rerun your workflows on old runners, because if the old runner is compromised, it can expand the attack vector for your CI/CD system, right? So that's the ephemeral nature of the runners. And one of the other aspect of ephemeralism could be if you are integrating, say, your GitHub Actions with something like HashiCorp Vault, the tokens that you use to access the secrets during the runtime should be short-lived, right? They should not be long-lived tokens. So that's on the ephemeral part. Next one is principle of least privilege, right? This means that your workflows or your runners, the process that's running the runner should not have any elevated privileges. It should only be able to access whatever it needs, right? It should not run in a God account sort of a mode. And I'm sure all of you here understand that a lot of us run our CI/CD systems in God mode because it's easy, right? It's just so easy because it can deploy and provision everything. That's not how it should be. To ensure security and zero trust, you should only have enough privileges that the workflow needs to complete its run, right? The next one is simple, understood, but very, very less followed, right? Make sure that all your runners and agents are running on proper software updates, right? You're always regularly updating the software. And last but not the least, the way we monitor our production systems, we should make sure that we monitor and observe our CI/CD systems as well. We should make sure that we go through the logs and alert or raise an alert if there is any unauthorized access, right? So all of these 6 things put together will ensure that you have a secure, zero trust CI/CD infrastructure. The next trend that I'm going to talk about is synthetic data generation. And a quick show of hands, if you folks, any of you have used production data for testing. Right. Now, Now, what if I were to tell you that if you use your production data for testing, you might be non-compliant with some of these laws like GDPR and the latest DPDP, Digital Data Protection Bill, that was launched in India as well, right? Now, there could be a variety of reasons. The three things that I think I can share with you is the first one, why this is non-compliant. Because testing as an objective was never shared with your customer or user when that data was collected. So likely it's a breach of consent or a breach of trust on why their data is being used and how it's being used. So testing is never an objective for which a data is collected, right? That's one. The second thing is, a lot of you would say, we pseudo-anonymize our production data and then use it safely. Let me tell you, even pseudo-anonymized data comes under the Act. Even if you pseudo-anonymize it, you are still breaching the compliance if you're using your production data for testing, right? Because that's one aspect. The second aspect is, the seemingly non-private information that's there in your systems, if you put them together, it can allow you to uniquely identify a person, right? So there are two aspects with pseudo-anonymization. First, it's not a guarantee of that you're not breaching the trust of the customer and you're not actually in non-compliant from a privacy perspective, right? And the third one is, I think what's PII, what's not PII is heuristic driven, right? There is no direct measure beyond the regulars that we all understand that what is PII, because then it's very contextual, right? It depends upon the industry in which you are. So it's all heuristic based, right? Now you'll tell me what is solution? Tell me the solution. So the solution is, there are now tools in the market that allow you to do a lot of synthetic data generation, right? And the first argument that usually people give when they're using production data is, hey, it's hard to understand the nuance of the real data. It's hard to get the right distribution from a statistical perspective on the test data. It's hard to generate that, right? Now I can say comfortably that there are tools which allow you to learn the statistical properties of your production data such that you can generate it very safely using these tools and then use it for testing, right? You can use it for performance testing, you can use it for load testing, you can use it for whatever you want it to, right? I'm going to talk about the tool in a minute. Then you can use the same tool generators for generating adversarial data, right? Like in the world when we are building a lot of models, when we are doing a lot of AI and ML, it's important that we think about how are we going to mitigate the bias in our models, right? And in order to do that, you can use things like ChatGPT or the tools that I'm going to talk about to generate bad quality data such that you can have the right guardrails in your pipelines and for your model output qualities, right? So that's generating adversarial bad quality data with synthetic data generators. Then I think synthetic data generation is also a very useful construct when we think about fine-tuning or pre-training models, right? It's because we know that in order to fine-tune any open source model, you need loads and loads of data, right? You need loads and loads of domain-specific data. It's hard to generate that maybe within the organization. So in order to make up for that, you can use synthetic data generation to generate domain-specific data according to your enterprise needs, right? And last but not the least, for use cases or outliers, which are very hard to replicate in real life, you can also use synthetic data generators for augmenting your data, right? Like the outliers or the expensive scenarios. And this is the tool that I wanted to highlight. It's called Synthetic Data Vault. It is a fantastic tool. It allows you to do data generation for single tables, for multiple tables with relationships between them, and even time series data. And the good thing about this tool is that under the hood, it uses the GANs and the VAE models or deep learning models to understand the statistical distribution of your production data, and then it can generate production-like data, right? A lot of Thoughtworks teams across the globes have been using this tool and pretty happy with the performance.
Right. Okay. So the last trend that I'm going to talk this morning, like how many of you drove to this event in their own vehicle? That's a lot. Do you know how your car works? Yes, no. Do you know how the transmission works? Do you know how the brake works? Like, why am I talking about this? Like, it's one thing to say that I know how to drive. Another thing to say that, I have empathy, sympathy on what's under the hood. Because the moment you know, you're a better driver, right? You don't need to know how to build your engine from scratch, but you need to know how the brake works, how the, you can't accelerate and brake at the same time. You know what's going on under it. The reason why I say that, I'm just channeling Martin Thompson, and he has a big thing on his website of knowing mechanical sympathy when it comes to systems. Uh, I want to say this because we use data everywhere now, right? And AI ML has amplified the need of data engineers out there. Um, Somehow, when it comes to understanding how things work in the data space, this is how we think of any data engine, right? There is some API, something that runs, and there is some storage, like very simplistic view. All right. I just want to take you through what does it really look like. Again, I'm abstracting, but this is a little bit more than I know how to drive a car in that analogy. So in reality, almost all your data engines, be it analytical, be it transactional, be it streaming real time, they all have this roughly 5 components, right? So there is a language front end, which is your SQL data frames of the world. And then these front ends get compiled into an intermediate representation. And there is an optimizer, and of course there is a execution engine, and there is a runtime for the engine, which has storage and all that. Now think about it. Think of your favorite framework, right? If you are using Spark, Spark has all 5 layers. If you're using Pandas, Pandas have all 5. If you're using Presto, Presto also has all 5, right? And let's say somebody innovates, right? Let's say Spark innovates something, right? And be it predicate push down. Like I'm going to push down the execution very close to my storage so I can do something like really, really fast. What happens to the ecosystem? Like others cannot leverage the innovation that one team or one product has done in one layer, right? Think of it this way, like when somebody has, I don't know, hydrogen-powered engine, it takes a while for other cars to catch up, right? The same way, if one engine optimizes, let's say I have a very good vectorized database engine, so I can run analytical queries faster. SQLite, for example, will take some time to catch up, right? But here is the thing, right? In the hardware industry, we have matured to an extent where that engine is like your CPU. Like you have one CPU for all the workloads, right? If Intel or AMD innovates, all your workloads are benefit, right? But that's not the case in data engines because you had multiple engines, and that is the problem. So this notion that can I unify data engines in such a way that if I innovate in one place, my ML ecosystem is benefited, my reporting ecosystem is benefited, my analytics is benefited. So this is what the engineers from Meta are asking, and there is a library called VLOX, which is like, you can almost think of one thing to rule them all. It's in a way too good to be true, but it is quite promising out there. So this is the engine that can unify every data engines that you have outside, right? Like be it in memory, be it disk, be it distributed, be it single machine, does not matter. It's because it is solving at such a low layer that once you have that innovation in VLOX library, everyone who's integrated with VLOX will benefit, right? And what they have done, they've taken the Presto code and then swapped out the Presto Java-based engine with this VLOX library, and the results are pretty amazing, right? You get anywhere from 3 to 6x based on their benchmark. So you should do your own benchmark to believe it. But the results are promising, right? And this is going to, I mean, if it takes off, you may not directly interact with VLOX as an application developer or a data engineer, but you need to know what's the engine that's actually powering your queries. And that's going to be VLOX in near future, and that's a trend to watch out for, right? So that's the last trend. And Anya?
Yeah, the last trend.
Last but one.
So yes. That's the last trend now, self-hosting LLMs. Now, you can sort of argue that probably all these large providers like that of OpenAI, Microsoft, GCP, Vertex, and the bedrocks of the world have sort of gotten a good head start when it comes to the Gen AI world, in particularly the large language models, right, LLMs. Now, we all understand that it takes a huge computational intensive infrastructure and huge cost to actually have that sort of an architecture and infrastructure set up, right? Now, and when we're using these models, we are using as a pay-per-user model, right? And it's every API call is going to cost you money, right? So there's a lot of money that we are talking about. And of course, as the volumes increase for your Gen AI applications, which are powered by LLMs, the cost can escalate. Now, what if I tell you that there are other options, right? And this promise is based on the fact that the open source ecosystem, when it specifically comes to LLMs, has have an explosive growth through and through, right? Now the open source community is a lot more cautious and worried about how do I make sure that I provide open source model architectures, and how do I provide high quality training corpora such that individuals and even small organizations paying for a large subscription based service, right? Because that's where the cost aspect also starts to come in, right? Because do you really need an Einstein to do a job of a college grad? I bet not, right? In that case, if you use a smaller model, fine-tune it or maybe pre-train it with your own enterprise data to do a very specific job, it solves your purpose, right? It gives you privacy, it gives you greater control on your integrations, on your software ecosystem, and gives you the benefits of the large language model. So that's the dual aspect of cost and privacy and compliance, right? And not far away from this is the IP and competitive advantage that you believe your data can lend to you when you pre-train your own model, right? Latency and offline access are the other aspects, because it's possible that I might want to provide LLM powered applications in an offline mode, and that becomes another driver for making sure that I host my own models. But with all good things, I think it's always a trade-off. It has to be a balancing act, because we cannot underestimate the amount of talent, expertise, money that you really need to set up something like that, right? And therefore, while you are making a decision to self-host for your own organizational needs, weigh in all of these factors, because if you really need to self-host, you need to think about the MLOps posture in your organization. You need to think about data platforms. You need to think about all the data-related aspects that probably you might be putting off. So it's not a non-expensive affair, but it's a balancing act. And with that, we come to the end of the 10 tech trends. This is a recap on the screen for all of you. And I hope all of you have taken away something meaningful from this talk. And you can talk about it, tweet about it, find us in the gallery if you are interested in one of them. Thank you so much.
Thank you. Thank you.